Hello and welcome you all for the next type of experimental design. In this class we'll see repeated measures design, which is also known as within subjects design. There is a reason for saying this within subjects design. We'll see that why we call it as within subjects. Here this particular design, it involves multiple measures of the same variable taken on the same or matched subjects. Under it there are two possibilities. It could be under a different condition or it could be over two or more time period. That means on the same subject we are going to experiment under different conditions. Earlier we used to have treatment 1, 2, 3 for a factor. All unique treatments we used to have. Here on the same subject, same block, we'll be using all possible treatments T1, T2, T3, whichever levels you have for a given factor. All of that will be using one over the other, but with a gap in between. So that's what is the meaning of different condition. Or one single experiment, we'll be measuring that outcome over a different period of time. Maybe day 1, day 2, day 3, repetitive results are taken. So that's the meaning of repeated measures design. In this particular case, that is repeated measures design, the subjects are typically exposed to all of the treatment conditions. This is the important feature of the experimental design, unique feature of the design. So all subjects, all experiment subject what you have, all treatments are all treatments are done on that. So it is quite different from what you have seen earlier, where we had unique subject and it used to have unique treatment to which it is exposed. So you have experimental block 1. On that you will do only treatment 1. Treatment 2 and treatment 3 are not done. For example, if you take a sample and a factor is temperature, and the treatments you will say that 20 degree, 30 degree, 40 degree. On the same experimental set, either you will do 20 degree or 30 or 40. So any one of the temperature would select and perform. For another temperature would select another experimental block. Whereas in this particular case it is not like that. On the same block you will perform the experiment with the different conditions 20 degree, 30 degree or 40 degree, but at different time interval. So what would be the advantage of this? The main advantage is in repeated measure design, subjects are become their own control. Their own control in the sense you don't have to maintain a separate control to minimize variation or to minimize the biasing effect of the nuisance factors. So when you don't want control, when you say that nuisance factor is reduced, effect by the nuisance factor is reduced, obviously the variability within subject, that means the natural variation because of small unnoticed errors will become zero or very low. When the natural variation becomes very low, it reduces to a small error term. In the ANOVA we have the error term, means sum of errors, which goes to the denominator of f test. That particular value MSE becomes very low, and that makes it a most powerful analysis in the design of experiment. So you can consider this among the experiment design what you have seen so far. This is one of the most powerful analysis. So here is one key idea, that is one experimental block is treated at a particular time interval. You will measure the result there, maybe a blood pressure. You do the same subject, measure the blood pressure, same subject, measure the blood pressure at different time intervals. Go keep on checking the data over the time. So this is repeated measures design. Another case is you have one set of samples A, B, C, D, E, 5 blocks are there, 5 samples are there. You will treat them at level 1, maybe drug dosage form 1. After some time interval, you will treat them with another dosage. After some time interval, another dosage. So the advantage is when you have individual samples tested, the variation among the batch are not considered. Whereas here, since you are using the same batch, to test for the other levels also, the possible variation among the blocks are reduced because you're using the same thing again and again. So there is no question of homogeneity among the blocks. It is homogeneous because you're using the same block again and again. So that homogeneity issue is reduced here. That makes it a more statistical, powerful statistical tool. Also, since you're using it again, since you are repetitively using the sample for all trials, all kind of treatments, the number of subjects required, number of blocks required are very less. If you take an example, if an independent group design is done, you will use 20 subjects per experimental group. So in repeated measure design, just 20 are sufficient for all trials. You take 3 trials, for each 20 you take it, 20 here, 20 here, 20 here. If you go for independent group, so total 60 subjects would be required. Whereas here, just the 20 itself you can use it again and again. So the number of sample size also reduced. Another advantage is it becomes quicker and cheaper because of the reduced number of sample size, and you can check it over the assess over the time also. But the most biggest disadvantage is order effect. There is one important issue that has to be observed called as order effect. It could be a detrimental effect also. Example, tasting of wine, for example. A dry wine may get a higher rank if it is preceded by a drier wine, and a lower rank if it is preceded by a sweeter wine. Now just imagine you are tasting some food material. If you taste a sweet sugar, you taste the sugar. Uh, Before you taste the sugar, if you have tasted something that is spicy, you'll even a little pinch of sugar you will feel that it is sweet. If at all you are other way around, if at all you have tasted some sweet item first, then you taste the sugar will may not be as sweet as in the earlier case. So the way you taste it or the way you perform the experiment, the order in which it is done, that is an important issue. So ordering effect is needs to be taken care always, how you perform the experiment. Then another issue here is it includes randomization. Methods include randomization. It allows for solving these problems you have to allow some time in between. This is one easiest method you can do the balancing of this order effect. For example, in between you taste the two things, you may have some maybe you can drink little water, or you just ensure that there is a difference between the difference of time, a difference of uh, mechanism, some mechanism introduced so that the tasting what you have done for this example are separated out. Otherwise this order effect will be there and it will interfere into the ANOVA. One most important or commonly used method is crossover design. This is a type of repeated measure design. Crossover design is a type of repeated measure design. Another type is parallel design. Parallel design in the sense the way you have done earlier, same thing, but you will have to repeatedly take the sample like this. So sam test number, treatment number 1, take it again. Treatment number 2, in block number 1, person A, take this, treat him with something again repeatedly. You take the results. But treatment person number 2, treat him at over the time. Take the measured variables or response variables, you measure it over the time. The difference between the two person or the two subjects is that they are treated with the two different drugs. Now, when you come to the case of crossover design, the case is slightly different. In the crossover design, first they are treated with one drug. The patient cross one treatment to another in between the treatments. In the case of parallel design, one patient is assigned to one treatment, he continues till the end. Whereas crossover design, say for example, day 1 he is treated with a drug 1, second day he is treated with a drug 2, third day he is treated with a drug 3. So one subject itself is used for all treatments. This is called as crossover design. So every patient receives both treatment AB, or if you have, this is case of two levels for treatment A, treatment B, two levels are there. For that, this is the case. So when you study for bioequivalence trials, because bioequivalence trials requires homogeneous subjects, so in order to analyze bioequivalence trials, crossover designs are most commonly used. The importance of bioequivalence trials is that in pharmaceutical formulations, how much blood concentration of a particular drug is achieved, that is most important. Whether it treats or not is not important. The importance is how much is the blood concentration level achieved with respect to one reference drug. So one reference drug is given on day 1, his her blood concentration level of the drug is measured. On day 2, the drug under test, unknown drug, some new drug you are taking, that is administered, so the blood concentration is tested. So since the same person is used again and again, so the chances of non-homogeneities doesn't exist here. So this is bioequivalence trials using crossover design. So here is one representative diagram. So group 1, so they are tested for a particular component, that is response variable is tested. They are treated, treatment A, they are tested for that. For example, drug his blood concentration of a particular drug or something is measured, you treat him, his same test is repeated after treatment A. Now second day you treat him with the second treatment, test him again. Group 2, you change the order, that is A first, B second. Here for this group you make B and A, reverse the order and test it. Now in this you can compare with respect to group 1 and group 2. What changes we have done is the order in which the treatment is done, this is what we have reversed. So this helps us, this is one of the nuisance factor, the order is becomes a nuisance factor. This is the blocking of crossover design. So this will inform us whether the treatments, that is order in which it is done, whether it is having effect or not. So you can, instead of treatment B, you can compare with the control also, you can reverse the control. This kind of analysis is good for chronic condition. Chronic condition in the sense the disorder or the disease does not get cured by any drug, but only that you had advantage of the treatment is it improves the quality of life. For example, take the case of asthma, there is no cure for it. So when there is no cure for it, fine, your treatment may reduce the problem or it may increase the problem, whatever it is. Otherwise, imagine you treat the person, he gets cured, so there is no time given for treatment using the method B. So that should not happen. In those cases, this kind of experimental designs fail. So experiment should be conducted when you have sufficient possibility of uh, treating with a drug A as well as drug B. Both should be performed. So the analysis of the experimental design, the responses are analyzed using ANOVA, two-way ANOVA or multiple ANOVA, as we have done in the previous cases for RCBD or Latin square designs. So you have a main factor, that is primary factor, treatment, and you can have the nuisance factor. Nuisance factor could be the way you are, that is between group 1 and group 2, you will measure it. So in this lecture we have seen repeated measure design and crossover design, how they are useful, how it becomes more useful by more powerful analysis, statistical analysis, by reducing the error involved, that is it becomes more homogeneous compared to other cases. That's the end of this lecture. Thank you.